Greetings, CS 345, 545 students. For week 3, we're going to be working with our first meaningful neural networks to do some meaningful task. And this is historically one of the first tasks that went into commercial production. A real success for neural networks. And that was recognition of handwritten digits. And there's a lot that can be done with that. We're just going to make a very simple neural network. And we're going to work with a really classic data set, which I'm showing right now on the screen. MNIST. NIST is the National Institute of Standards and Technology. It's a department of the federal government. Back in the 1990s, they started creating data sets to use for machine learning. And among the data sets they created, and it went through several generations, were these handwritten digits. So if you've been reading along on the information in Canvas, you've seen this, a description of this. And this is the data set we're going to be using. And I have here on the screen some example digits taken out of the Wikipedia article. You'll notice that there's quite a variety in the way this works. These digits have been, in some sense, normalized. They're all more or less or pretty closely in the center of the screen. They are pretty low res. They've been turned into 28 by 28 pixels images. That's 784 pixels. So even though 28 by 28 is low res, 784 is not a small number of data points for reading one digit. You'll notice that there's a bunch of different ways of drawing sevens. That every way you can think of making a 2 with or without loops is in there. Ones are sometimes written occasionally written in a sort of European style with the hook on the top. O's are never perfect circles or hardly ever, You're seeing what's going on here. So this was an AI task. And this data set became kind of the standard that people used both for developing new methods and machine learning methods and image recognition methods, and also because people could use this data set, everybody could use it. That meant there was a common data set that people could use for comparison. So I working in my lab and you working in your lab, since we had the same data available, we could test on whatever data we wanted, we could train on whatever data we wanted, but ultimately when we published something, we had to run it on the MNIST data, and that gave a really common way, that enabled this to become, much more rigorous science, because different methods could then compare to earlier results by other groups working on the same data. You could say with some certainty we managed to make a 1% improvement, knowing that it wasn't because the data was easier or something like that. So the other data set, so this is what you're going to have for your homework. And the other data set we're going to use in class, in this case recordings, is this thing over here, which is what? This is called Fashion MNIST. And they basically took the MNIST data type of thing, and these are 28 by 28 grayscale images of articles of some clothing. And from a link in the exercise, you can get the list of, this is t-shirts, trousers, pullovers, dresses, all the way down here we have sandals, sneakers, boots, Um, so here we go. T-shirts, trousers, okay, pullovers, dresses, like that. And one of the things you're going to notice is that this is a lot harder as an image recognition task. Some of those pullovers and some of those, what were they? The outer garments, coats. Some of the pullovers and some of the coats look pretty similar. Here's the pullovers in the third row here. Here's the coats in the fourth row. And there's a lot of very similar looking things. So we're not going to get nearly the accuracy as we did with the digits. The overlap between the data sets, humans probably wouldn't do a great job on making some of these distinctions. And again, here we have the sandals and the sneakers, and you can imagine that some of them, and here we have the boots, and some of the smaller boots, like that one over that I'm hovering my thing over, might be confused with some of the bigger sneakers. So yeah, so this is going to be a much harder data set, but we'll get a whole lot better than chance, but whatever. Okay, so that's the data we're going to be using, and what we were going to discover in your notebook is that this data is actually so pervasively useful that it was actually baked into the libraries, that you don't have to download this data. It comes with the TensorFlow libraries for machine learning in Python, and we can just call it up and use it. So that's another convenient thing. The last thing to note is that the neural networks that we're going to build are doing a classification task. So these aren't generative neural networks. We're not generating pictures of digits or of fashion items, although we will do something later in the semester, I think. I mean, we currently have that planned, where you can, generate digits, as as a generative thing. This is a classification task. So there are 10 different digits, and your job will be to make a neural network which has as input these 784 pixels from one image, and then it says which digit it is. And for the digits, you can get pretty good. And the same thing for the fashion items. So we're making a classifier, which will have 10 different outputs from 0 to 9, representing the correct digit. So that's the test that we will be working on. So that's enough for this video, and we will continue in a moment.